Hi students, I'll try in this educational video to technologically introduce the shear force and the normal forces inducing bending moment occurring in the cross-section of a loaded beam, of course, as simply and as clearly as possible. Okay, let's go. Well, let's consider a beam, for example an I-beam, supported by a pin support and a roller support and transversely loaded as it is depicted by the figure that you see in this slide. This beam will be naturally subjected to bending, and if we examine a cross-section in this beam, we will find internal forces developed to maintain the equilibrium. These internal forces are the shear force applied parallel to the load, so the shear force is tangent to the cross-section, and we have also normal forces applied perpendicularly to the cross section. You can notice that the normal force on the side of the load is compression, while the normal force on the opposite side of the load is tension. This tension and compression will induce bending moment, and I will further explain this afterwards in this educational video. Now I'll talk about the shear force, and as it is depicted by the figure that you see in this slide, higher shear force magnitudes are located in the web, while lower shear force magnitudes are located in the flanges. This means that most of the shear force is concentrated in the web. And please keep in mind this observation because it will be useful to assimilate the shear connection that I will talk about in the next educational video. For the normal forces, they are depicted by the figure that you see in this slide, and as you can notice, higher normal forces magnitudes are located in the flanges. The compression force is located in the top flange because it is on the side of the applied load, while the tension normal force is located in the bottom flange because it is on the opposite side of the applied load. And the lower normal forces magnitudes are located in the web. This means that most of the normal forces are concentrated in the flanges. And please keep in mind this observation because it will be useful to assimilate the moment connection that I will talk about in the next educational video. Now I will further explain how normal forces will induce bending moment. So we have the cross-section view depicting the normal forces applied perpendicularly to the cross-section as compression on the side of the applied load and tension on the opposite side of the applied load, and they are amplified as we approach the flanges. If we examine the beam view, compression and tension are modeled as it is depicted by the arrows, and you can notice the amplification of the compression and the tension as we approach the flange. Of course, here the tension and the compression have the same magnitude, but they have an opposite sign. This will induce naturally a bending moment, as it is depicted in this beam view. That's all for this educational video. Please, if you have any questions, remarks, or suggestions, please mention it in the comments. Thanks a lot for your attention.